Howdy everybody in YouTube land. What we have here is a little Repairathon. Now, I thought about just doing a video for each and every single one of these, but having a whole bunch of mini videos versus just having one full video with substance, I chose to just do one full video with substance. So, let's start this off by reading our letter. So, thanks so much for taking the time to look at these boards. I have a total of 5 boards. Whenever you have time, let me know what's wrong with them. So we're going to do that first. We're going to do some troubleshooting to figure out, what we got going on here. Please let me know cost per board. We have 3 Macintosh portable boards, and I'll label them 1, 2, 3. So we got boots up with garbage on screen, no chime. So just for the sake of conversation, let's make some predictions here. Could be wrong, could be right. Don't know. Number 1 says boots up with garbage on the screen, no chime. That means we're not running code. Something's holding up the bus. So we've either got a ROM problem or we've got a swim problem or open traces, something like that. Second, boots with happy chime continues to reboot every few seconds. That's a RAM problem. No chime, but when interrupt press, occasionally it will sad chime with error code. It could be open traces, peripheral, something like that. We don't know. Color Classic 2, no power, dead, egret. Color Classic, no power, dead, egret. So those are my predictions. How far am I off? Not sure. Anybody watching this video, let's keep some tally and see what it is. I got addresses covered up anyway. So, all right. So let's move on. We're going to go right down the list. So number 1, 5126, boots up with garbage on the screen, no chime. So let's pull that one out and take a look at that one first, shall we? Getting all of this in frame is a little bit easier said than done. But the good news is they're packed well. We've even got one that needs to be refrigerated. Unfortunately, I have not refrigerated this anytime soon, so it might have spoiled already. Not sure. So anyways, that's number 2. This is number 3, and then number 1. So this is the one I want to start with. Just go down the list. So we have our Color Classic here. Just doing a quick little look at it. It looks like it's already recapped. So I don't need to do anything crazy with it. Figure out what's going on with it though. And then we have a Color Classic 2, which is in this little air tube bubble sarcophagus. So we will get to those in a minute though. First things first is we need to get to our number 1 board and see what we got going on with that one. Alright, so here's board number 1. Let's see what we can gauge from first observation. It's recapped, so we don't have to deal with any of that. And it looks like a lot of poking and prodding has already happened here because I can see little scratched off traces there. I can see it here as well. There's some of it happening down there. So someone has already been poking and prodding at this thing to figure it out. See what we got on the back side. Oh boy. Never know what's going to be up with some crop circles. That can never be good. So, I don't know. One thing we can do is... See, there's a little bit of scratching going on there. So upon first observations, I'm not seeing anything extraordinary. No eaten away rotten traces that are popping off at the top of my head. There might be an open via or something, but I'm not really seeing it. Then again, I didn't recap this board, so I don't know what kind of damage was there prior to cleaning. But from what I can tell off the top of my first impression eyeballs, I don't see anything of any significance. Sometimes we get trouble down here, get some voltage issues. So we got to check all of that. But aside from that, I don't see anything that's standing out to me that's of immediate concern. So most likely, unless we have a break right at the chip or underneath the chip where you can't see it, we probably have a bad IC. And from what I've understood when it comes to portables, the swim is the first thing that goes when it comes to a situation such as this. That scares me because these are getting harder and harder to find. And they're getting more expensive because you have to basically scrap a whole nother logic board to get that chip. But that's where we are now. One other quick observation is I don't like how these capacitors were just tacked on. Now, I understand in cases where your soldering iron just really can't get in here to do anything about that. I just don't like that. But that's just personal preference. I mean, it's not going to really affect anything if it's soldered on well. But, alright, without further ado, I'm going to do some dry checks here and see, make sure we don't have anything crazy going on. Alright, so we're going to grab a speaker. We're going to energize this thing. So step one, just to plug a speaker into it. I don't have a screen handy at the moment. Power supply's dialed in. Just got to plug this guy in. Reset the PMGR. And then power it up. Ooh. I don't like that. That definitely acted like bad connections to me. What I'm doing now is feeling for chips that are getting excessively warm. These 74 series chips should not get warm. So if they get hot immediately on power up, they're bad. So that's one good way to troubleshoot these. That one is. You know what would be good here? A FLIR, one of those little infrared thermal cameras. I don't own one, but... So let's cut the power off again. Reset the PMGR. Well, it's trying to chime. But I don't think so. Oh, yeah. It's almost like the audio hardware is powering up in a weird, undefined state. Okay. I want to remove the ROM jumper. Ah, yeah. That made a difference. Yep. So it's able to read ROM. Because if not, then undoing this pin would have... Yeah. Alright. Yep. It's trying to read ROM, but not very well. Okay, step one. I think before I start pulling off the swim chip is to check the traces between the ROM buffers back to these 74 3 or what are these 74 244s. These are buffers. So what we do is we check the data path between here and here, because if we have a problem there, it's not going to work right at all. So as long as if I can confirm the data path between here back to the CPU, then the second thing to do is pull this swim and see what we get. All right, one thing I wanted to make a note of, with how strange the sound is acting, it's just, I've not run into that before. But one thing I've noticed is when I get my hand near the ASC, you hear that? That is a symptom of a floating line to the ASC. Now, it's either an address or data line, or the chip select, or the DMA, or it's one of those lines. It's definitely... I've noticed that. Yeah, and it's changing the current draw too when I do that. I need to look at this. We got to pull the schematics out now so we can take a look. Decided to take a look around the caps using the flashlight method, because that's usually where you're going to see the most signs of trouble. And look at that. There it is. Hold on, I got to get this positioned right. So let's see. Where is it? There it is, right there. Just on the corner of C9. See that? There's no copper there anymore. Yeah, I don't know what connection that is yet, but that's definitely one. We got another one. No, those look good. But that one's gone. Alright, let's look up underneath the board, because where that is going to be... Which... Oh yeah, look at all that. Look at how those traces right there are just eaten next to R88. I don't know if it's going to those two or where, but that's definitely problems. So we're going to need to investigate that. Let me think here. Where does that go? Because I have you two right there. If I flip the board, that goes under the cap. So I need to remove this cap. Is it that one? No, it's the one below it. It's this one. No? I don't know. It's hard to say. But yeah, I gotta get that cap off so I can look up underneath it. But also, yeah, yeah, you can definitely see it now. Do you see the green? Yep. Mm-hmm. That's going to R75, I think. Or next to it. Yeah, R75. What's R75? I don't know. Let me look. Alright, found it in the schematic. R75. What is that? Sound chip select. There you go. There's the fault right there. So this trace is open like right here, I think. Which means R75 is on the output side of that 244 on the top. And since it's a straight shot, it goes down and over. So, yeah, goes down and over. And I bet if I measure that out, that's going to pin, what is it, pin 9. And pin 11 is going to the glue. So, yeah. Actually, since this is the backlit board, that may not be accurate. But according to the schematic, yeah. So, pin 11 goes right there. No, that's pin 11. Anyways, I'm kind of all over the place. Let me get a meter out so I can figure out where that stuff goes. Alright, so now we have the schematics in front of us now, and I have this board. I want to make sure and see where this goes. I have a feeling that this is going to the chip, so let me look. If I connect you here, which is broken, so I have to follow you down to about there. Which as we already know, it goes to 11. No, it doesn't. It's going to 9. So 244 pin 9. What are you? So this makes it harder to do. These are the originals that was used to make the PDF. Oh, 9. So, slam and the ASC. Okay, so pin, that's the ASC. Move you out of the way. So I have the ASC here, so this is U13C pin 9, which is the 244. Again, this is for the non-backlit, and this is a backlit, so it's not the same. Oh yeah, pin 9. Okay, so pin 9's going off to the sound chip, but I don't think so. Hold on. 11. Okay, so it's backwards. They have this reversed. So 11 is going to the glue chip. So pin 11, yeah, that's right. So pin 11 goes to the glue chip. That's right. 9 goes off to the Apple sound chip, which is, let's see, sound CSF, which goes to pin 11. So 17, 19, 11's right here. And I bet. Now it's broken. Well, there you go. That's why we got this problem. So, okay, if we follow that over here, let's see, it's getting between here and here. I can kind of get it through there. Yeah, it's there. But it doesn't make it. Nah, there we go. There's our break. So how do we fix that? Unfortunately, the break is over here on R75, which is a 47 ohm resistor. So unless I run a wire all the way around, which is ugly as hell, the only other way to fix this is to run a drill bit in between the layers of the board. But before I do that, I want to actually check this capacitor, because where is C9? What is C9 used for? C la la la. I don't know. So the problem is C9 is likely, because there's audio. So we've got C9. Oh, yep, C9 right there. Pin 1. Alright, so one of the positive input of C9 goes to 11 of the Sony sound chip, which is back here. Yeah. Open, of course. And the speaker, I'm pretty sure, is connected to the other one. Yeah. Anyway, so, because C10 should go here. Wait a minute, I'm on the wrong one. So, you go there? No, it's connected. Never mind. Alright, so the other end needs to go to the jack, which is over here. And it does. That one does too. Yeah. It's a blended. Okay, yeah, we're good. It's connected, but that one is not. So there's two options. I can either drill a hole through there and run a patch wire between the two sides, or I can take a resistor and solder it between, what was it, 11? Or no, 9. Yeah, from 9. So 9. 11's going here. Yes. So now if I go from here with a 47 ohm resistor over to here and make it ugly, I think what I'm going to do is I'm going to get my small drill bits, and I think we're just going to drill a hole in there. That's what we're going to do. Alright, so what I've done is I've got my little drill bit set from Amazon. Nothing special there, just cheap garbage bits. These things break super easy, so you have to be careful. I don't use a Dremel or whatever. I carefully work these by hand until I get the results I want. And if you're not careful, if you cattywampus off to the side, you will break this bit. So I'm being super, super careful. So I've run a hole through this already now. So my goal is to hopefully grab and run a piece of like 30 gauge wire through here. I've got this old stuff from the 1990s, so it cuts a lot better and solders a lot better. But let's see. So if we take you and run it through this hole, yeah, there we go. So that's the perfect bit for that situation. So I think actually what I'm going to do is we'll just solder you here first. So we'll just cut you and solder you right there. So now it's connected there. From you there. And then we will take a look at it from this point. I've already removed the capacitor so I could check the traces underneath, and they're okay. So for how long I don't know, but they're okay for now. Alright, so we're gonna do you. We'll just cut you right there, because this is a lot easier to deal with than, you know, this trying to like run a wire across the other side of the board. So that's what we're gonna do. We're just gonna do it this way. There. Good enough. So we should be connected there. And hopefully we're still connected there. We are. Okay. Now that we've done this, move you out of the way so I don't get that all mixed up anywhere else. We'll grab you. Get our little speaker connected. And can it be this simple? Can it be this simple? Well, maybe. I mean, anything's possible. Turn our power on, let it stabilize. Connect you. Reset the PMGR, and then power on. Ah, well. There's not going to be any sound, because it would be helpful to actually put the capacitor back in its place. Now, wouldn't it? So let's do that. Because we got to get that back in its place. This cap is very squirmy. There we go. Try it again. Hey, we got a chime. Wow. Wow. Nice. Nice. That is an amazing feeling. All it was a break here in the circuit path. So basically this guy right here, the sound CSF, it was broken between here and here. So I had to drill a hole in the VIA and just run a patch wire. So we're good to go. Now I'm going to go grab the screen and make sure we're good on that front. I have a feeling we probably are, but I need to make sure just to know. Alright, so I keep this test display around for exactly these scenarios. So here we go. Yep. That looks good. I mean, besides the line in the screen, but this is a known bad screen. You can kind of see it. So, well, almost. But yeah, this is a known bad screen, so. Perfect. We have the nice little question mark of what we want to see. So we're good. This machine is working. It's working perfectly fine. I might grab a floppy MU or something and see if it'll start, but a blue SCSI would be great, but I don't have, these boards are not set up for termination power, so I can't just plug a DB25 blue SCSI in there and plug it and boot it. I'd have to plug it separately in the wall with a separate. Anyway, so it's working. I'm going to go ahead and shut this thing down, and we are going to move on to board number 2. So this one's working pretty good now. So let's see, referring back to what my analysis might have been. I thought it was a swim chip, which it was not the case, so I was wrong with that one. I can't remember if I said it was Open Trace or not. People watching keep tally, see how far off I actually am. So this one's good to go. And if I look at it, if we take a closer look now, you can see the trace that is now patched going through the board. So set this aside and we'll grab out board number 2. All right, so now we're off to the second board here, which is in this weird foam padded refrigerated anti-static bed. I've never seen such a thing. This is a new one for me. Not gonna lie. Anyway, so this one apparently just boot loops, which almost always, 100% of the time, is RAM related with these portables. Now, the thing is, though, we don't know why the RAM is the issue yet. It could be a bad chip, or it could be an open trace. Oh, looks like it's another Macintosh portable. Alright, so, first inspection. Well, it's marked number 2. We have... Ooh, a lot of patches over here. Again, not surprising considering how bad... What in the world happened to that capacitor? Wow. It's supposed to look like this. Not like this bumpolumpus mess. Anyways. We got patches and all that. This one, the complaint is, like I said, boot looping. So, if I were to hazard a guess, our problem is going to be over here. Now, the real question is, wow, there's a lot of damage through here. The issue with this, though, is there's no schematics for the RAM section of this board because it's different. The logic is different for this compared to, say, a non-backlit portable. So using the schematic for this is going to be useless. We can check everything from here on back with the schematic, but everything up here, including these logic gates, are all different. So that's not going to work. And it's probably because this handles combining, because this chip here is designed to put out multiple signals for a huge array that would be on the non-backlit, which this doesn't have. So this has to consolidate the select signals as well as generate the refresh signal, because this is pseudo SRAM and not actual SRAM. So we've got to create the refresh signal, and some of that's responsible for that too. So anyways, let's fire this thing up, get this thing all wired up, and see what it does. Alright, so we're plugged in, so we're just going to go ahead and turn the power on. Make sure there's no crazy draw. There isn't. Reset the PMGR, and we'll fire you up, and we'll determine the symptoms. No. Oh, there it goes. Yeah, same symptoms. But I notice it's drawing a ton of power. It's drawing 1 amp. That's excessive. So I want to make sure we're not getting hot. Let me check the RAM. No. Oh, a little bit warm. Not really. No. Oh! Fuck! That was hot. Holy God. Oh my God. Sorry. Wow. Ooh, 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 ooh. That's gonna hurt. Wow, that's gonna hurt. Right here. Wow, the right sound I see is toast. Wow, is it shorted? Did they make a blob here by accident? No. Yikes. Yeah, that's not gonna work. I don't know if that's causing our problem, but it certainly can't be good. Okay, so we're going to have to grab the hot air tool and remove that, because we got to get that out of the circuit before we can do any further troubleshooting, because that thing is toast. In fact, well, I don't want to damage any circuitry, because otherwise I would turn it back on and grab a temperature probe and show you. Yikes, look at that blister. Look at that blister. That's going to hurt. Alright, now we're going to remove this chip. Alright, so hopefully get this chip out of here, because, yeah. Oh, I can smell the cap juice. Alright. Hopefully that... Yikes. So I know for a fact that one's dead. That is gone. Alright. Let's see. Does it boot loop now? How does our current draw look? Much lower. Didn't solve our problem. We still have a chime loop, but we don't have that anymore. Shut that off. So we still have a chime loop, but we don't have that one being a problem anymore, so... Or, well, this, I mean. Alright. Let me clean all these solder joints off. Why use braid when you have a Heiko? Because it'll pull all that right off, no problem. So, alright. Okay. So we have a RAM problem for sure, but the only thing I can think of is, let's see, how do we approach this? The best way to approach this, I think, starting off, is grabbing a meter. Find the data sheet to this chip so we can get a pin out, right? And then what we do is, because a lot of these pins are in parallel, we measure them all against each other, make sure there's no open connections, because I see a lot of capacitor damage up here, so there could be an open trace or via between here and the rest of these. So we need to check you and against all of the other ones. If all the trace is good, at that point you're literally just, you're going to be stuck plugging and going. In other words, pulling a chip, replacing it, see if the problem resolves. Pulling another chip and replacing it and seeing if the problem resolves. Until you find the chip that's bad. That's really the only thing we can do here. And there could be multiple ones bad, because maybe there's more than one. Because I can't just pull one and replace it and then put it in a good stash if it doesn't fix it, because it could also be bad, right? But I see corrosion here, and I see corrosion up here, and definitely down here where this 74 AC 138 is. I might need to replace that as well, but I don't know yet. So step one is to get all the traces measured out. So we're going to do that. Alright, so I'm going through these traces here. So we've got here to there. That's in parallel. Most of these should be in parallel. Like such. No, we're good there. Nope. Alright, so I need to make sure that's not a bank select line. So that's 1, 2, 3, 4, 5. Okay. 2, 3, 4, 5. Nope. There's definitely a break between here and here on that last, or the five pins up from the bottom. So we'll move up to pin the next one over. Okay, that might be normal. Yep. 3. Next one over. Yep. So 2, next one over. Yep, same way. Okay, this is ground. Yeah, I'll say. Alright, so 2, we'll run you there. Yep. 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 Yeah, that's where the break is. So we've got, I found one. So we can make a patch wire between here and here to fix that. So we definitely got a break there. So now we're going to go to the next one over. We should be connected here, here, and here, but not over here. That's right. Now I can check over there. These are the data lines, by the way. Good. Nope. But I can check over there. Should be good to go. Yes. They're over. Should be over there. Nope. That's right. 4 over. Okay. That's right. Okay. 1, 2, 3, 4, 5 over. Anyways, you get the idea. Alright, so I went through all of the chips, and this is what I found so far. The VCC pin is completely open on this one, so that's going to have a serious implication on the whole kit and caboodle. Now, there's a break between this one and this one on this chip only. So this pin's broken on this chip, this pin's broken on this chip. We have the break between here and here, which I got on video. And then we've got a break between here and here. Now this chip here, this third pin over is not visible anywhere else. Everything else is connected. So these three, no, there's 1, 2, 3, there's 4 wires, 4 patch wires I have to make before I can attempt to test this thing again. Now what I'm going to do is go up underneath the board and check the vias to see if they're open, because they probably are. If I remove this chip, we'll probably find the break to these two right up under here. Now this one's going to be broken probably because there's no trace going from here to here. So chances are it goes over and then around. So it's probably broke up under here somewhere. And then I don't know about up here. We'll see. Alright, so if we look at the bottom of the board, after I do a lot of trace checking here with the top of the board, there's a lot of rot. And it's everywhere. You can see it through here. You know, and it's bad throughout here. And of course, if we move up closer to the RAM, look, there's a lot of rot through there too. Like that trace there is probably open. There's definitely a lot of rot going on here. That's likely why we've got like 4 broken traces on top. It goes all the way through here. This board was stored in very poor conditions. It's probably left out in a barn, put out to pasture. So, yeah, unfortunate. It is what it is. So I'm going to check some of these real quick. Then I'll probably just patch it from the top side. It'll be easier. Alright, so unfortunately I can't find the data sheet to these. However, I did find a cross-reference to those. And that are the Toshiba TC518129 CPL, which has a data sheet. So at least I know where my pinouts are. So if I look, we have a break here, which is address 10. And then we have a break here, which is VDD. We have a break there, which is A0. And then on the other one, we have a break here, which is chip select. So yeah, all of those breaks definitely shouldn't be there. So that is why this thing is boot looping. So we got to get that fixed first before we can, you know, even start to think about there being a bad chip. So we got to get the board talking to it. Now, I did it off camera, but I already buzzed these back, address and data, over to where they go here. This is the mux that selects the rows and banks and stuff. And then the two columns are selected from over here, but all of these are connected in groups through this chip here. And they're all good. The address connections back to over here are fine. The read-write lines, all that stuff's going to the other side of the board. There's no breaks there. The breaks are just contained in here. So let's patch all of that up. All right, so all of our patch wires are installed as such. Now it's a matter of, is it going to chime loop all over the place, or is it going to work? I guess we're going to find out. So let's energize our power supply. Let's get you connected in here. Reset our PMGR and turn it on. Nice. No more chime loop, and we're not drawing 7 million amps of current either with this chip removed. All right, so the other thing we need to do is we need to go fetch a chip out of my parts bin because I don't have any of those just off the shelf, but that's not a big deal. No more chime looping, so that's a good thing. So let's get the screen hooked up and see what happens here. All right, so let's give it a try. See if we get any kind of initialization whatsoever. It looks like, yep, there it is. There's our mouse cursor. Awesome. Yep, there we go. That tells me the RAM test passed. So there we go. It wasn't a bad chip. Fortunately, it was just all of these broken traces. So this is one of those boards where I think I want to test the floppy disk access and the SCSI to make sure it works because of the amount of broken traces I found so far. I can't guarantee any of it. So we're going to test all of that here in a little bit. But it's a good news and good thing that we got this thing to work. So all it was that. All right, before I forget, I needed to replace this Sony chip. So I got a new one on there. I took it from a battery bombed board. The old one's over here. So hopefully that fixes that one. Make sure it doesn't get hot. Yeah, because that burnt. Nope, I think we're good and we're not drawing a lot of current. So we're fixed there. Last thing to do, like I said earlier, is to grab a blue SCSI, figure out how to power it. Not quite sure with that part yet. I think I have an idea. I'm going to get a blue SCSI, plug a blue SCSI in here, make sure it starts up, and we should be good to go. All right, blue SCSI is connected. Let's turn it on. See if it accesses the blue SCSI. It's powered off the battery. It does, and it gave me an error chime, and that's probably because the image that's on here is not set up for this machine, which is okay. But the good news is it's reading from the blue SCSI, so I know it'll work. So now I'm going to go grab the floppy EMU and plug that in and make sure it works with that too. All right, here we go. Floppy emulator's plugged in. So we're just gonna, I got it set for read only so we don't corrupt the image. We're gonna go Lido boot and see if it'll detect it. Oh, it detected it. Will it read? Yes, it's working. Awesome. That means the swim chip is good. That is really good news. So since we're locked, we shouldn't corrupt anything. I'm gonna shut it off. We're gonna plug it into the next port over. We're gonna do that one. Make sure it reads. And it looks like it's going to. Yep, there it is. Last thing to check is to plug it in the rear, which is now in the rear, back there. So let's try you. Make sure this works. Yep. Looks like it. Yeah, we're good. We are good. So this board is officially repaired. So we've got this one good to go. I'm going to go ahead and bag this one up, and we are going to move on to the next one. So we're hammering these out. So what did we learn? What was wrong with it? Well, yes, I was accurate when I said it was a RAM issue. Now, Fortunately, it wasn't bad RAM, it was just broken traces, but I didn't expect that. So that's all fixed. SCSI works, floppy drive works on all 3 ports. We're ready to kick on to the next one. Alrighty then, we are on board number 3. So, I think this is our last portable board, so let's get this thing out of the bag, take a peek at it, and see what we're going on. Now, this one is a 5120. This isn't a backlit board like the other two, so this one, at least the schematics will match. You know, it'll definitely help. That far goes anyways. I don't know, I can't English today right now. It's the next day and I am really tired. So let me get this out of the bag. So the bag was mislabeled. It is not a 5120. This is yet another 5126 backlit board. Wow. What did he do there? Yikes. Yikes, yikes, yikes. There's definitely some shenanigans going on, especially in this corner. So let's get this thing connected here and see what it does, because yeah, I don't know. So we set the PMGR and attempt to power it on. Oh, well, that button doesn't work. Slow chimes. Alright, well, this doesn't work. No. Alright, well, that's certainly not a good thing. So this switch is bad, for one. I'm not surprised. Alright, I need to get the screen out so I can figure out what that error code is. Alright, so here we go. Screen's connected. Let me get the power on here. And let's try to energize it. Well, couple things right away. We've got a sad Mac. I can't really tell what it is, but we also have a lot of corrupted video, which tells me there's a broken address data trace in here somewhere. Oh, we're kind of getting additional writes. Alright, now it's not chiming, so we've definitely got problems. It's looking like SADMAC code 14, maybe CD36, CD38, which is a problem with the VIA. It can't talk to the VIA. So that would do it. Yeah, now we're not even getting a chime. So this thing has all kinds of problems. We've got write issues for one. Not wrote that time. So yes, we're going to have to start checking some traces in this circuit down in here, I think. I think we've got an open trace under here somewhere. Because we've got corrupted video, we've got unable to communicate between the VIA and the PMGR, SADMAC. So in here somewhere, we've got broken traces. So we need to get in there and figure out what's going on. Alright, so I did a quick rundown between the video chip and the RAM. And there's no breaks there. But before I get delving down the rabbit hole too much, I decided to plug this thing in and check the 5 volts going into the system. And we're at 4.7 volts, which is probably too low. And I bet it's a regulation problem. Because if let's see, get this shoved in here somewhere. I bet you it's a regulation problem. So if I turn the voltage up, yep. Yeah, it's not regulating. And judging by what I see here with siliconed in capacitors and all this other nonsense, I'm not surprised. So we're going to need to deal with this. But first, I want to get the voltage to a certain point where I think it's stable enough to see if it'll at least try to run. So let's do that now actually with while I have the camera on, or at least attempt to. All right. Let's see. Nope. That is a no. Nope. So we have a similar problem. The voltage, I mean, the voltage is low, yes, but that's not why we have this problem. So we need to keep going, hunting down the line here. So I'm probably just going to figure out at this point, because from the SADMAT code, I'm getting 14 CD38, which is, if I look at the chart here, it says CD38, Power Manager was never ready to start Handshake. It's possible the PMGR is bad, but it's not likely considering it turns on and works. It's probably the CPU not able to talk to the VIA, or the VIA not able to see this chip, and because we have the corrupt video, I think the two are going to be related. So perhaps there's a data address line that can't see both of these chips. But that's a guess. So we're just going to go through there and check all of the address bus and the data bus back to the CPU and make sure that those connections are good. All right, so I've decided to check off camera the traces between here and the data address bus, as well as the select logic back to the glue, and it's all good. And I also checked the traces between here and the PMGR, which could throw that CD38 code, and it's also good. So that tells me the problem with this board is far more ominous. I did notice right away that we've got a broken pin on this display connector, so that's an issue. That could be why I've got garbage video, but I don't know. That could represent some lines, but not what we got going on. What we got going on is very intermittent. So the problem that I have is, I didn't go through all of these traces yet. I just did some few quick checks between here and here, and it's also good. The traces between here and here are good. So I'm starting to suspect what happened is, based on what I know and what I observed with this particular board of the voltage regulator not actually regulating, I have an itching suspicion, because I've seen this before. What's happened here is this voltage regulator is not operational, and this logic stage saw the full DC voltage input. So if this had a 7.5 volt input, this stage saw 7.5 volts. And what's leading me to this conclusion even more is, look at this switching transistor that turns the power on and off to this stage over here. Look how dark it is and how black it's gotten from heat. So that tells me that what we've got going on here is damaged chips. These chips are bad. Which ones, I don't know. We already know we have a bad video chip just based on how it's acting. So this chip here is definitely bad. The second chip that's likely bad is one of these two. And that's unfortunate, because you're not replacing this without a parts board, and you're not replacing this without a parts board. So, and I don't have any more parts boards because I've used all the parts up, because like I said, I've run into this before where I've had to change half of these chips before, this being the number one most common failure. This is usually the first in line that goes before the rest of them does. So it's looking more and more, I'm going to finish checking the rest of these, but it's looking more and more likely that this is EOL and has become a parts board. Can't save them all. It just is what it is. And this is why it's super critical that you check everything everything before you power these boards up for any length of time, especially this 5.2 volt circuit. Because as soon as you plug this connection in, and as soon as you energize this board, this 5.2 volts is present. It's not present over here until you turn it on, but it is present here. So if you don't have 5.2 volts here, or if it's wildly out of regulation, stop and figure out what's going on before you try to energize this board. And I can tell because of how damaged this section is. And there's still a missing trace or two in here somewhere, which is why regulation is not properly over here. But it's too late. It's too late. It doesn't matter. All this section over here has got to be replaced. So, and I've, like I said, I've got like one or two boards that belong to other customers that they left them here because I've had a similar problem. They're junk. So, it's unfortunate, but that's where we are with this board. Gonna check the rest of these traces out, and chances are they're okay because I'm not seeing any physical visible damage even under a magnifying glass. So, unlike the last two boards, this one's done. So 2 out of 3 was not bad. 2 out of 3 was not bad on the Mac Portable. I could fix the third one if I had a parts board, which I've used up all my parts because of I keep running into those issues with the portables. Anyways, moving right on down the line, we have now the Color Classic board from the lot of boards. And this one, the complaint on it is it does not power on. So I'm going to suspect that it's the egret or a trace to and from it. I don't know. We'll see that in a minute. But more importantly, I don't really have a good bench set up for this because I'd like to be able to probe this on the table without needing it inside a Color Classic. So I have a way around that. But first, let's get this cover off so we can see what's going on inside. Now that we have the board out, we can take a quick look at it on first glance. So, there's nothing immediately obvious standing out to me that I can see that would be a severe problem. I did notice there's a little bit of a trace break there that was patched, but that's not a big deal. But also, the egret, or otherwise known as CUDA, and now they are not interchangeable. CUDA and egret are not interchangeable. The source code to this chip had leaked out, and it goes into those details. But anyways, so I can see some shenanigans down here where this was worked out a little bit, but nothing that's standing out to me. And if I look on the back side, I don't see any dark spots where there could be corroded traces or anything like that, but that doesn't necessarily mean anything. Aside from that, that's all I see so far. So first off, I need to get the bench set up in a way where we can actually see what's going on. So yeah, give me a minute on that one. Don't do this unless you know what you're doing, but what I did do was I disabled the horizontal output stage so we don't get any extra explosion factors and surprises. So other than that, the power supply section should still run. So this board should be energized with standby voltage. So if this board were working, as soon as I hit the power button, it would turn on. And it's not going to because there's something wrong with this board. But now with this setup here, I have a way to energize this board without needing to, reach into a case that you can't get to. So we're going to use that to determine what we got going on. So if this chip here is responsible for managing power switching between the standby power and the battery power to supply this chip. So I need to make sure this chip is supplied, and I need to make sure we have a 32 kilohertz oscillator in here as bare minimum before we even can do anything. All right, we are energized, and I have my oscilloscope probe on the crystal oscillator and 32 kilohertz. So that chip is alive. Now, whether the ROM and the internals of that chip is good is yet to be determined. But that means we have power, standby power, and all of that. So it is live. It is working. Now, what I want to do is I have the schematic pulled up right here of the CUDA slash egret slash whatever they want to call it. So I can take a look at a couple of things. One, I want to take a look at pin 24, which is the connection for the ADB power button. And then 26 is the signal that goes off to the rest of the system, which turns on the main power. So if 26 is low, the main power supply is not running. So technically, pin 26 should be high when I go to turn it on. So I think 26 is right here. And yep, it's low. So if I press the power button, I get nothing, which is to be expected. Now, once you turn this power supply on, there's a R1 as a pull-up. So as soon as you turn the power supply on, it's going to stay on if this chip is not alive, if it's not running code. So that means if I short it out to the next one over, and then now look at this, it's on. See the light? So if I meter this out now, it's probably, well, it's kind of, hold on, we got to get this, oh yeah, I'm stuck on AC coupling, so let's switch it to DC. Whoops. Yeah, that's what I thought. So if I connect you there, yep, we're high. So I got 10 times 10, so 2, 4, 5 volts. All right. So let's look at the reset pin, which is pin 15. That should be high. And it is not. All right. Well, that explains a lot. This chip is deader than a doorknob. So we got to find another one. So here's our problem. This chip is dead. But the 341S0417 was only ever used in the Color Classic. It's specific to this machine. So finding that is going to be near impossible. So I'm hoping I can steal this one from this battery bombed board, which I've already used to fix another board, because remember we took the Sony chip off to fix the other portable board. So I'm going to take this egret off and see if we can use that to fix this one. No guarantees it's going to work, because some people say this is CUDA. The schematic shows CUDA and egret, so I don't know. If it does turn on with the replacement chip, we got to make sure it keeps the time, and we got to make sure it will work with the ADB, keyboard, mouse, and all of that. And if all of that works, then the chip will work fine. Otherwise, we're going to have to come up with a different solution. So let me get this off the board, and we'll get that moved over here. Alright, so what we're going to do now is just pull the chip off of this board here first, and we'll get it figured out. And there we go. That one's been removed. So now, set you down that way, and then we're gonna, let's see, I need to get this up off the table so it doesn't melt the table, because that would be a bad thing. Alright, so now, this is gonna be fun to get in here. There it is. Let the board cool down a bit. So chances are, we're going to move you out of the way, this guy here is toast. Alright. To leave that go. Alright, so That one. Okay. Grab you. Put you there. Actually, before I do that, I want to take a look and make sure I don't see any other little weird traces or issues or anything, and I do not. So we're just gonna take you. There we go. Just solder you in place. Having this ferrite bead here makes it really hard to actually get it to work. Wow. It's causing the solder to... Okay. Alright. There we go. Now, real question is, does it work? Does it solve my problem? Well, let's find out. Here we go. No, it does not. Does not work. Yeah, I'm not surprised. This chip is pretty darn specific. So, but then again, it's possible that this CUDA does not work. I mean, it came from a bombed board, so who really knows? But I'm going to check it real quick. Make sure we have an oscillator. We do. It is running. Yep, it's good. Okay. So this is our control signal here. Nope. Alright, so let's check our trigger signal. Yeah. Trigger signal is good. So our problem... Let's see. Yeah, this is not good. Check our voltage, VCC. Yeah. We're good. No, we got nothing. So, darn. Alright, so we know that the egret that I stuck on there did not work. So, instead now, I'm going to take this parts board here, and we're going to try to take the CUDA off of this one, because this is an actual CUDA. So, I'm going to grab this one, and hopefully that one works. We're going to find out. It's literally just trial and error, because the chip that this classic board needs, you can't get. There's no other board that has it. So I'm just hoping that one of these newer ones has the same or similar enough instruction set where it just works. But honestly, I don't know. So I'm just gonna keep pulling parts until I find something that works. This is my last shot, because this is the only CUDA that I have. If this doesn't work, then that color classic board is unfixable. Not without blank chips and a programmer, neither of which I have. There we go. Parts board. This one was a battery bombed Apple Network server board, so I've been using it for parts. Okay, so let's try this again, but this time we're going to use a 0788 and hope that this one will work. Because quite frankly, I don't know. I'm hoping one of these works. It may or may not, so we're going to find out. Alright, so we've tried 0850. That one didn't work. Now we're going to try an 0788 and see if that one works. So, and the chips are all the same. The only difference is it's the programming that's on the chip that varies. Here we go. No! No. Does not work. Alright, well, unfortunately, the Color Classic boards need that very specific chip. That is a no. Let's see if it'll jumpstart. Because it may or may not, because the 417 would jumpstart. So, do we have an oscillator? We do. No. Okay. It turns on and then shuts back down. So it's got different behavior compared to the original. We've got no activity on the reset line, and then it shuts off. All right, well, so the CUDA is not compatible. All right, well, darn. So the 0850 is not compatible. That's assuming it's any good. And then the 0788 is not compatible. So, all right, well, I have another Color Classic board that's a parts board that actually goes to my machine. And I don't think it's any good. But this chip might be okay on that board. I don't know. So, oh man, this one's this one hurts. This one hurts. This one might be another one of those unrepairable situations. We'll have to see if I can find something. Alright, so this is my parts board, which came from my machine. It's certainly seen far better days. So, I don't know if this one turns on. We need to find out if it does or not. Man. Crap. Alright, let's see. No, that one doesn't turn on either. Gah! Yeah, I think that's what was wrong with this one. It has a bad egret as well, which is why it was thrown in my parts bin. So unfortunately, we're going to have to move on to the next board, because I can't... This one's not fixable. Actually, what I've determined is the problem with this board is we're missing the 5-volt standby to this CUDA chip. It's missing, so that explains why it's not working. Which makes sense because it's probably broke over here somewhere and we're not getting standby voltage back here. Which is going to cause a problem. So, what I'm going to do... actually, no, that won't work. I'm probably just going to pull this chip because, I mean, why not? Let's just, since I know this is the right chip, again, I don't know if it's any good. We're going to pull that one and see if that one will actually solve our problem. So, I mean, what is it? Third time's a charm? So, I mean, why not, I guess? This is a parts board anyways. I'm going to set you over there so I don't lose track of which one's which. Alright. We're just gonna try that out for size. So this is, I mean, this board could still be repairable. I don't know. But not without, you know. So, alright. We're going to take you out of there. Put you back in my parts stash. Grab the other board. Do the same thing. This is the one we were trying to repair. I gotta pull this chip again. I think what happens is the program is all the same. The difference is they change the pinout based on the type of logic board it's in. That probably has a lot to do with it. So this one may run, but not going to run in this board. Alright, so that's been pulled. Yeah, I don't know how many times I can rework this thing, but... yeah. Yeah, well, let's put like for like, the original chip back on this board, just from a different board, so... I don't like giving up easy. But it's one of those things, without a new chip, I don't really know, you know? Because I'm looking at the signals going in and out of this chip, and... there's no reason why there should be anything else wrong with the board as far as the power management's concerned, so we'll see. And again, this chip here, I don't know if it's any good either. I'm literally not able to eliminate variables. Okay. Alright, well, is it third try as a charm, or what is it? We're gonna find out. I hope this works. I'm getting tired. Let's see. No! Either I have another bad chip, or there's something else wrong with this board. Because that's a problem. You know, I'm doing some probing around, and I just realized something. So, and I don't know why I didn't pick up on this before, but, so, when I turn the power on here, it's not running, right? It's not turning on. But what I noticed is if I probe the crystal, which you can't see it, unfortunately, I don't have a good camera angle there, but if I touch the crystal is not running until I touch it, because it will slowly increase in amplitude. It's like I touch it, slowly increases in amplitude, and then it collapses. It's not supposed to do that. It's supposed to be clean. So that makes me think there's a problem in the circuit that my scope probe is compensating for. So you know what? I'm going to leave my probe on the crystal. Now I'm going to try to turn it on. There it is. It just came on. It's working. Wow. Yeah, it's on. I don't know if you can see it in the camera, but that little green LED is lit up. It's on. Wow. Okay. So this chip is good. My chip is good anyways. So we know that chip is good. So what are we going to do now? Well, I'm thinking our problem is in the crystal circuits. Alright, so I'm doing some quick dry checks here. First thing I'm finding right off the bat is we have, the numbers don't match the schematic. I don't know why, but it doesn't. But, so this guy's the ground. This guy's not. So this C56 is open to ground. To verify that, I'll grab the parts board, which is right here. Let's see, yep, right here. So if I do the same tests over here, that one's connected to ground. So C56 is open to ground, which is very unusual because I don't see anything here. See, the via itself is connected, but it's broke to the ground plane. Yeah, it comes up through there. So that is so strange. Yeah, it's broken. All right. Okay. Well, let's yeah. Totally didn't expect that. So all of my testing and swapping I did over here was probably in vain, because yeah. So here's what we're gonna do. I'm just gonna, clean up the solder joint or the wire here real quick. We're just gonna resolder you, solder you. I'm just gonna go between here. And then we're gonna go from there to here. Alright, well, does that work? Really good question. Oh man. It would be hilarious if it was that simple. If it is, I'm going to put the original chip back on here. Let's see. Here we go. Wow. It's on. You can see the little green LED. So, wow. This whole time, it was the darn capacitor that was open from the, Alright, well, I'm going to swap these chips back around. Alright, now. Swap the chip back out. I took the one off, put this one back on. So hopefully, if that's all it is, I'm going to scream. Oh my God. There it is. That's all it was. The darn... The ground is broken, which is weird because there's no evidence of damage visibly at the via on the top or the bottom, so you would never notice. But then again, I've noticed with these boards, they've all been ultrasonically cleaned. So any evidence that would have been there is gone. So that's the problem with ultrasonic clean. You can't really do that until you understand all of the faults and where everything is. Anyway, so now it's on. It's running. It's freaking working now. So let me go grab a blue SCSI real quick. Go plug you in. And see if it'll launch the blue SCSI. Because I think this has turn power. It does. Yeah, if I see blue SCSI access there, then we're probably going to be okay. Maybe. Yep. There it is. It's working. Wow. Wow. The darn... Yeah. Okay. I'll be calm, cool, and collective. Maybe. So, no idea if these chips will work or not, because I do not have the whole time. Anyways, you know what? It makes for fun content. So, this one appears to be working. So, let's move on to the next one, because we don't know what we got going on here. So, alright, so that's working. We're good there. No problems with that. Now, I don't know if the video and ADB and all that stuff works yet, because I don't have the computer ready to be plugged in. So, that'll be a bit later. For now, let's move on to the next and last board. Alright, now that the pain in the butt of the Classic is out of the way, we are now on the fifth and final board, the Color Classic 2, otherwise known as the LC550 board. So, once again, taking a look at this board, I don't see anything crazy other than you can tell someone's done some resoldering work there. And of course, someone was moving and messing around with the egret. Now, this is the 788, which I think is the same as one of the ones I just tried to use. See, 9410. What are the rest of these chips? This one is 9329, 9327, 93. Okay, so someone replaced that. That's not the original. Because all these other parts have 93 date codes. Except for that one. So that's a bit suspect. So you can't just throw it, because I think the 788 is the CUDA and not the egret. And they are not, like I said before, they are not compatible. So someone replaced that, hoping it was going to fix the problem. And it's not going to. So I got to find the correct one that goes in here. But before I do, again, let's confirm the symptoms. So power on. Let's see what happens. As suspected, not much. Alright, so I gotta grab the oscilloscope and... Wow, that one's missing the standoffs. Huh. Grab the oscilloscope, let's check the crystal, let's check all that stuff. But chances are, it's got the wrong chip in it. I gotta pull that out and replace it. Of course, do I want to fall down that same rabbit hole again? I'm not sure. I don't know. Let's just play it by ear. Alright, so we do not have any power. Let me check for oscillator. Well, I kind of have something there, but I kind of don't. So... Alright, well, I decided to check the oscillator before I pulled it off. I don't know if that's right. That seems a little low. But also, it's doing the same thing the other one does. You know, when I touch it, the pin, it slowly comes up. It's not supposed to do that. So I think, before I go down that same rabbit hole again, I think we've got the same exact problem going on here. We've got a problem with either the oscillator crystal itself, or there's an open trace to one of the support components, because that's not normal. In fact, let me go grab the scope probe, clip a doodly-doodly-doo here, and then get it connected into the crystal. I want to do this single-handedly, which is Kind of a terrible idea, but let's try it. Let's go here. All right, we're connected. Now, obviously, if I hit the power button, nothing. It still may be the wrong chip. So let's power cycle this thing. Huh, that's different. So, what's it do now? How about that? It's on. All right. Okay, so we've definitely got a problem in the crystal circuit there. Let me get some power audio into it. Let's see. Do I have sound? Yep. Perfect. Okay. So our problem is definitely not the chip this time. God, that would have sucked to go through all these chips again just for the same exact problem. So the 788 is in here. It looks newer. Someone's replaced it. But that's not our issue. Our issue is either this crystal or another one of those support components. So we don't have a schematic to this one, I don't think. So we're just going to have to wing it. And that's what we're going to do, is check all the support components. All right. And now that we've got the system diagnosed, it will run if I ground the scope probe to it again with this last board. All right, it's time to do some trace checks. So here's the crystal. We're going to check here. Good, 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 good. So let's do a ground check to this cap. No. This one. No. Okay, so this ground is not connected to... Wait a minute. Let's see. Are we here? Alright, so the two grounds are isolated. That makes a lot of sense. That one's corroded. So for some reason the two grounds are isolated. Anyways, let's check this again. Okay, it's there. That one's not there. Okay. Well, here we go. Here's a video right there that's grounded. Let's check it. Huh. Same exact problem. Really? So there's a patch of ground plane here that's not... What in the world? So it's open. Where does it go? There's a via right next to it. It goes through the board right to that stupid C5, the negative side of C5. So there's a via right there. I bet you it connects to an inner plane. And I bet it's open. So, wow. Okay. Is the negative side of the cap connected to anything? Yes, it is. So it's connected there. It's connected there, which is also connected here. But is it connected here? No. One. Same exact problem. Same exact problem. Now, it's one thing to run into one, but two in a row? That is just mind-boggling to me. So, our problem is, now that because the via is open here, I can't, this whole plane is open. So, what I'm going to do, I think, is just, yeah, that's what we're going to do. I'm just going to solder it right there and go down to the next pad up, which is going to be right here. So I have you right here, which we're going to solder to, or try to. There's a V there. We're going to go from there. So that's what we're going to do. We're going to solder wire right here. And then we're going to go right there. But in order to do that, I got to trim off the rest of that. There we go. Okay. Let's try that again. Plug your cable in there. All right. Does it run or does it not? That is the question. Here we go. There it is. It's on. Wow. Okay. Perfect. All right, let's grab the blue SCSI. Plug the blue SCSI in. Turn the standby power on. And then, bam. All right, let's see if it'll access the blue SCSI. Should. Yep, there it is. It's starting. It's booting up. Wow. So the problem was the silly another open trace, literally right at the ground via. That's twice in a row. It's so rare. I've never seen it. I've done a lot of trace repair. But yeah, that's a first for me. Yeah, it's starting up. I got blinky blue LEDs, so there we go. Board number 5 fixed. All right, as we verified with those last two boards here, they're working perfectly fine, so we can wrap this one up. So in the end, what did we have? Well, board number 1, we had the broken connection to the chip select signal on the Apple sound chip. And then number 2, we had the RAM traces and the bad Sony IC. Then number 3, unfortunately, cannot be repaired because I don't have enough parts. I don't have a parts board, so that'll just go back to the original owner as it is. And then these two had the exact same fault, which is funny because I would see that on one, but both of them? Who knew? So that was an adventure. If anyone was keeping tally on what I projected the problem was to be versus what they actually were, I don't know what my percentage is on accuracy. Probably not very good, but hey, you never know. So, anyways, I'm going to wrap this one up. This is a big little, yeah, Repairathon for Macintosh logic board. So if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.